Okay, here we go. So I'm going to make a Fibonacci sequence algorithm, and you're going to make a golden mean sequence algorithm. Okay, so I'm going to walk you through it. So the first thing is, let's go ahead and kind of think about what we want. Now, let's go ahead and recall. Here, I got math type. Let's remember that the Fibonacci sequence is going to be like this. It's going to be 1, 1, 2, and then we start adding those 3, and then 5, 8. Okay. So, and we can do likewise with the golden mean. Remember, it's going to be here I'm going to call it GLD, and we're going to lose the first value. That's really important. We're going to have one less, right? So, and then we're going to get 1 divided by 1, which is going to be 1. And then 2 divided by 1, which is going to be 2. 3 divided by 2, which is going to be a 1.5. Okay, and then I'll quit there. Okay? And so our goal is to go ahead and start flowcharting this. So the first thing we need to do is compute these, and then you're gonna set up how to compute these. So let's go ahead and jump into our flowchart. Okay, you see I've got my flowchart shapes. You can make flowcharts in other software. We're just doing this for ease here. Those of you that know about flowcharting probably have a preference. Okay. Okay, so here's my start block. And here we go. So the first thing that I need to do with the Fibonacci sequence is I need to tell it these first two ones so that you know what to like add together, right? Because then 1 plus 1 is 2, 1 plus 2 is 3. So let's go ahead and set that up. So we're going to insert, and this is going to be something that the user is kind of going to say. So, so something like the Fibonacci number at at 1 equals 1. And the Fibonacci number in the second spot also is 1. Okay? Now, at this time, you need to put in a golden mean first value. Okay? And how would you do that? How are you going to write it? Remember, it's going to be GLD. Go ahead and try. Okay. Once you have that set up, you should be able to go ahead and insert another one. So we're going to insert us another shape. And let's go ahead and jump into the computational step. So, my first computational step is actually going to be an assignment. Oh, I don't like this. You can do it however you want. You don't have to be as picky as me. N equals 1. No, n equals 2. I have 2 elements decided. However, notice that that's only one golden mean. You only have one golden mean, but your n is still going to be 2. We're going to count the Fibonacci number, okay? I really like this box. I'm just going to use it now for my computations. Okay, so what are we going to do now? Now we need to start going through. So n equals n plus 1. I need to go to my new number of n. So if n was 2, 2 plus 1 is 3. So we're now at 3. The Fibonacci number at 3, at n, which is 3 right now, equals the Fibonacci number at the previous one plus the Fibonacci number at the one that's like 2 ago, right? The previous 2 numbers. Okay? Okay. At this time, So that's going to compute the next Fibonacci number. You need to type in now what's going to be the next golden mean number, which, remember how we computed it, is the two Fibonacci numbers divided. Okay, try that now. Okay, once we have those in, we can go ahead and put in our question. Oh, I don't like that one. I want a diamond. There you go. I want a diamond. That's going to be my question. Okay. And I realize my shapes are a little bit big, a little bit cumbersome. This is where some software that does this comes in a little bit better. Okay. So now, what do we need to ask? Right now, I'm going to ask, is n greater than, say, 50? I'm going to terminate at 50 terms, okay? You could ask if the golden mean is to the correct accuracy, and you can set up accuracy up here, or you can do just like I'm doing. We're just going to do a brute force. I want to see the 50 terms, okay? Right now, n equals 2, then we went to n equals 3. Okay, let's start adding in some flow lines. I'm going to connect this to this, and you'll see how I connected it to the box. That way, if I move it around, it stays connected, okay? That's a bit of a trick, and if you do it wrong, it won't quite connect, and it'll get frustrating. So then let's connect this box over to this box, okay? And then let's connect another one, this box to this box. Then we're going to do it again. This one to here. Okay, and you can use a down arrow for your flow of direction. I'm going to assume we know what it is. And now I'm going to insert. Okay, we have a few ways to do this. We could do it with the weird line. One of these types. Actually, that's not a bad idea. So we go over. Okay, what happened? Oh, that's totally not going to do what I want. I thought it was like in Illustrator. Sorry, fine. We're going to go over. Then we're going to go from that point up. Okay. And now we're going to take our flow of direction. I'll give you an arrow on this one, though. And we're going to hit that. Okay. So then is n equal to 50? No. Go back in here. Remember, it was 3, so 3 plus 1 is now 4, and we're going to do it again, then 5, then 6. Okay, we're done with this, so we're going to go ahead and end. So let's end. And what do we want to do when we end? I like this box. When we end, we display some information, right? So we print out this Fibonacci vector that we have. And you're going to print what? The golden mean vector, okay? So, and then we have an end. I like my start. Let's make it like an end. And it's game over. So we go ahead and insert these. Oops. You were supposed to connect. Okay, and now you should have one that's now set up for the golden mean as well, okay? You ready? Let's go ahead and go program this sucker. So, I don't know the best way to do this. So I start my algorithm. That's just kind of when I play it, right? Here's what I'm going to do. I'm going to initialize these vectors, and I'm going to do it very lazily. This is bad for pre-allocation of space, but it'll work great, I think, here. It's been a while since I did it in MATLAB, but I think we're good here. Let's try this. It might yell at me and say, consider pre-allocating for speed, but we don't care. Okay, so I've initialized these. Now, oh, I'm not supposed to do yours. Sorry, I'm not doing yours. You have to do that. You didn't see that. Okay. Now I'm going to go ahead and say the Fibonacci value at the first is a 1. The Fibonacci value at the second is also a 1. Okay, now you put in your golden mean right now, which you have in yours, right? And n equals 2. Okay, I'm going to go ahead and do this as a while loop. You could do it as a for loop. I'll do it as a while loop. So we'll say while, okay, n is less than or equal to 50. I don't know. This is going to get huge on us quick. Okay, but the golden mean will converge, right? So while this is true, okay, n equals n plus 1. That's my step forward. The Fibonacci at n equals the Fibonacci at n minus 1 plus the Fibonacci at n minus 2. Okay. You have a golden mean formula to put in, right? You know what that is. And then is n equal to 50? The answer is no, so we go around. Eventually it is, so we end the while. Okay, so the first thing we're going to do is just display this Fibonacci value or vector here. See what we get. I have no idea. Here you go. So we're going to run. And this is so Fibonacci sequence. Okay. And oh my, it's like awkward because it's like sideways. These are just terrible numbers. It just gets so big so quick. I think we go into like some sort of weird notation. 1 times 10 to the 10th. Yeah, this is no good. Let's move us down to like 10. When you do your golden mean, you can run that many because it's converging. There you go. Okay. And we can go check. Is that what we thought we were going to get, right? Here, let's not run the prime. Let's run it just regular. Okay. 1, 1, 2, 3, 5, 8, 13, 21. Do you believe it? It seems pretty good, right? Okay. So now you should be able to display your golden mean. Do you believe it? Okay. Let's go ahead and plot this. What do you think, like, I don't know. What should we call it? SZ for size. I like SZ for size. The Fibonacci, okay? Equals, I think I could just type length. Fib. Okay, let's go see if this works. Okay, so can we display this value? The size of the Fibonacci value, okay? It's got 11 numbers in it. Does that seem viable? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, we're good, right? Okay. So, now, with that, let's do this. Let's plot this thing. Let's plot, oh, look at this. It gives me help nowadays. Wow, this is amazing. Okay, it's been a while since we did this. I'm going to go from 1 up to the size of the Fibonacci vector, okay? That made me a bunch of x values. It's like 1, 2, 3, 4, out to the, in this case, 11, okay? You can run yours for longer. And I'm going to go ahead and plot the Fibonacci values with that. Now, for the line specification, I don't know. Let's use UHCL colors, green and blue. What do you think? Can we do a green line? Will that work? All right. That looks cool to me. And then can we put an X label on this thing? Like iteration. And how about a Y label? I don't know if it doesn't like the fact that I don't have these other things. This is going to be the Fibonacci value, okay? And yours could be a golden mean value, right? And so let's try to run this. Do I get a plot? I get a plot with an add. which is kind of cool. Okay. Not the ad, but the suggestion there. Okay, and what you can see is that we're like increasing exponentially, which makes sense. It's not quite exponential, but it really is turning into that very quickly, right? And so there you have it. So yours should look different when you plot the golden mean. You're going to get a nice convergence. It's actually going to stop off at a number, right? And so this gives you an idea on how to do that. Okay, good luck.